My involvement in the ERMITAGE program then is to look at or introduce a modelling capability into ERMITAGE to actually predict future stores of groundwater. So this is invisible compared to surface water, which everyone is familiar with, lakes and rivers, etc. But it's actually beneath the surface of the water, out of sight, really, that gives most of the resources for irrigation and drinking, etc. Understanding groundwater is important because already at the moment in certain parts of the planet the natural aquifer resources are already being very stressed. And as we move into different climate regimes where we may be getting less rainfall or different type of rainfall that isn't good for the aquifers, we're going to see that stress actually increase. The aspect of the modelling that I've been working on is actually to translate climate predictions from monthly values into daily time series, because it's actually the daily delivery of rainfall that's important in refreshing the groundwater stores. The daily delivery is important because if you were to receive in a particular part of the planet a month's rainfall in one day, for example, all of that rainfall is just going to run off on the surface of the ground, which is not what you want when you want to recharge the deep water stores. For me, the value of the ERMITAGE project is actually being wholly interdisciplinary. So we have socio-economic scientists right through to the physical scientists at the other end of the spectrum. And we're all coming together really to provide meaningful tools for decision makers to actually plan for future climate change. I think I'm fairly optimistic as long as we come together in programs such as this and actually deliver the right kind of tools to make the decisions, because the longer we leave it, and in fact the inactivity that's maybe been apparent in the past decade isn't doing any good. But I would say now that we're beginning to really shift up a gear or two, I'm becoming more optimistic.